Hey, looks good.
Hey, hello there, everybody. Welcome to the Astro Hour, the SBAU Astro Hour. It's 60 minutes every week of hardcore cutting edge cosmology and a lot of fun for and from SBAU. That's the Santa Barbara Astronomical Unit. I'm your giddy host, Ronnie Herron, and I'm going to be introducing my fellow club members in a moment, including some of the other board officials. We are headquartered up at, and we have our meetings at the beautiful Santa Barbara Museum of Natural History, which is our home base. You can find out the whole story at sbau.org. Nobody does outreach like we do. We're everywhere. For example, we'll be at Westmont College this Friday night at dark next to the observatory. Our programs here on Zoom are presented on YouTube, and this will be episode number 255 for January 12th through the 18th of the brand new year 2026. And these are our cosmic topics this week. Scientists now have an explanation, they think they do, for the red giant star Betelgeuse's odd shape. The Orion armpit has a Betel buddy. Could be the future of NASA's Mars sample return program could be doomed. There's a comet out there we're following, discovered way back in 1911, that goes out beyond Jupiter and comes back every 8 years. Goes by the name Shamash, not to be confused with our local Indian tribe. That's Chumash. Anyway, got to focus on a protoplanetary nebula out in constellation Monoceros with the handle HD 44179. It's the Red Rectangle Nebula, even though one of the photos calls it the Red Square. What's the
Uh-oh.
youngest known supernova left in our galaxy? Well, it's 11,000 light years away in the next arm of the Milky Way out from ours, 10 light years across, and it's in Cassiopeia. And yet another supernova remnant is a riveting bow shock pulsar JO 437 4715, photographed by astronomer Adam Block. Let's meet the crew, shall we, ladies and gentlemen? Captain of our starship and a weekly professor as good as any astrophysicist. It's Mr. Tom. Tom, give me a break. Mr. Jerry. Tom and Jerry are on our screen today.
Right, we are.
President Jerry Wilson. Hi, Jerry.
Hello, and hi, Joyce, and hello, Riley and Calvin.
Yeah, we got to get them on the screen with us.
Yeah.
Have some good looking people for a change. He's married to a very lovely lady and a big supporter, First Lady of the club, Pat Porgy. Also married to a Pat is our outreach coordinator, Chuck McPartland, in front of the Ukrainian flag, in charge of all of our events, and he's everywhere. Pat is his wife, merchandise manager, and our beloved treasurer. Tim Crawford joined us, resident lens expert, telescope guy, and a definite supporter. He's married to Karen. We have Tom Whittemore, who's married to
Morning.
Maureen,
Yeah.
and is a chronic birder. I guess you're a member of the Audubon as well
Yeah.
as us.
Yes, yes, yeah.
Okay. I would like to say that any one of you guys, except for me and maybe Crawford, could make incredible university or college professors of astrophysics, but you really were out in Westmont for how many years?
13?
13 years.
Yeah, 13.
Did you live in that lab or did you also have a classroom?
Oh, no, no. I only taught in the electronics lab and then the physics labs. So 13 years for the physics, and I think the last 8 years, I think electronic circuits.
You
Okay, and
live
then
in physics. You live in physics labs when you're a graduate student.
Right, right.
this
You're
was an
changed.
electrical lab. It's all electrical.
Yeah,
Bulb.
I mean, I kind of rewrote the program there. We were building analog computers by the time I left. I don't know what's going on now, but that's what I did. I kind of taught myself how to make a lot of stuff, in
Sure.
grad school and after. Um, I never had an engineering course in my life, so we just like Jerry probably build a lot of stuff.
And Professor Jen Ito took over for you. She's doing that now.
Yeah, no, she doesn't do electronic circuits, as far as I know. Alan Nishimura was the guy who was doing it after I left. I don't know if he's still there. Um, But Jen is a really good researcher, an astrophysicist, awfully good teacher. Um,
And remarried or married for the first time.
yeah,
Just got hitched. We may
yeah.
have her back.
She married the head of the, I think, the choral director at Westmont. I think he's
Excellent.
Chinese American. She's Japanese American.
And
Did
she
you want
goes
to meet
by
her?
Gen G now.
Yeah, yeah. So she took his last name. Yeah,
Gen G.
yeah. I mean, her maiden name was Ito. A
She'll
very
probably
familiar Japanese name.
she
Good thing
probably
his last name isn't Z.
Uh,
she'll
well,
be there at Westmont.
As Jerry would know, there was a really great quantum book written by a fellow named Z. Z.
Really?
Yeah,
You
yeah.
think she'll be at the star party you have at Westmont Friday night, third
I
Friday?
can't make
Absolutely,
it
yeah.
this Friday. We have a music event. These music events are starting to show up on these third Fridays, so I will not be able to be there. But I'll be at the Sunday Solar. I love doing that with Tim. Tim and I were the only guys there, and we got 55. And we argued over it because I think I got 28 and he got 27.
Is that right?
Oh,
I got to tell you, Whittemore, even though we miss you at some meetings, you do a darn good job on our newsletter every month.
thank you. Yeah, I really like doing that. I really enjoy it. And every now and then I do get a submission for a poem by a lady. I forget her last name. It's like Schiller. Oh, Stillman. Stillman.
Suzanne, yeah.
I've never seen her, but she puts out these really nice poems.
Yeah,
Okay.
quite
And of
nice.
course, I depend on Jerry to help, have a great article every month.
So you think it'll be in the February newsletter, maybe?
Right. Well, Jerry, I'm just, Jerry pretty much always gives me an article.
I'm talking
And
about the poem.
often they have to do what we're talking about, previous, like here. And they're always good.
Well,
So,
Jerry, in addition to being one incredibly knowledgeable guy, as all of you are, has a sense of humor like the rest of us. So let's see the weekly tunes from the president.
yeah,
Tunes with two O's, TOONS.
yeah,
Got about 5 or 6 of them sent to us. All he found out how to do it in one email instead of
right.
7 separate emails. And some of these are great. Read that one to us, Mr. President.
Not to brag, of course. I can always tell when the dinosaurs in movies are fake.
Pretty good.
What? They don't use real dinosaurs? I thought they did. My God. Okay. Talking Heads. Chuck, you think you can get us through that? Did you read this?
Yeah, sure. Yeah,
Talking-
there's a couple here, and she says the inspection revealed a few problems. It looks like your planet needs an alignment. And the guy goes, "Oh," and she says, "Yeah, your magnetic axis is 400 miles off center from your rotational one," which kind of applies for the Earth, I think. And
Yeah.
he says, "Is that bad?" And she says, "The unbalanced magnetic field could cause radiation anomalies over the South Atlantic. Have you noticed any spacecraft equipment failures in that area?" And he says, "Yeah, there have been a few actually." And she says, "We can give you a loaner planet while yours is in the shop. Is a gas giant okay?" And he says, "Well, I'd really prefer a solid surface." And she says, "Sorry, it's all we have, but it'll just be for a few days."
Good.
Wow.
Damn loners, isn't it? Talking about the Bermuda Triangle.
Boy, but if you want a really mixed up magnetic field, pick Jupiter.
Yeah.
I'm going to let Tim Crawford read this one.
Yeah, hand it off to Tim, this one.
Uh-oh, I haven't read these. Rule of math. If it seems easy, you're doing it wrong. Yep.
There you go.
Yep.
All right, Tom Whittemore.
Oh, it's a medicine, the world of medicine. Okay. Pediatrics is the first one. Not sure. It's this little kid, right?
That's right.
Yeah.
Yeah, that's
Oh,
kind of a
okay.
visual cartoon.
Yeah. Anesthesiology. Looks like it's asleep. Okay. Cosmetic dermatology, dressed to go to a dance. Orthopedics definitely had some problems. Dentistry, happy teeth. Radiology,
Oh
pretty
boy.
much, it looks like an X-ray, maybe.
yeah.
Gastroenterology, the gut.
Right.
Obstetrics, baby.
Oh, my God.
Ophthalmology, good eyes. And cardiology, heart. Okay.
Is that, before you go, is that called the Hippocratic symbol? Is there a name for that thing?
Chuck, caduceus? Caduceus?
Caduceus, I think, is the twin snakes.
Yeah.
And there's another name for the single snake.
Okay.
I can't remember it right now.
Yeah.
Well, I'm talking about the figure itself that represents medicine. I recall back in the 50s, there was a half-hour black and white show, I think called Medic, starring
Yeah, that was a
Richard
long time
Boone.
ago.
And it always put my lump in my throat, my heart in my, because, oh my God, what is it?
When I was
People are
researching,
dying.
when I was researching for today's topics, there's something that we have that's in Serpens cauda. And I had to look through probably close to 24 sites before someone would commit to the cauda part. They just kept saying serpens.
Yeah.
Oh, okay.
There's two serpens.
Yeah. Yeah. Cauda's, of course, the tail.
Well, it's a nail and a snake. I don't understand that at all. Go ahead, Mr. President.
Did you know that in the movie Interstellar, the water planet scenes were actually shot on Earth?
They didn't take it out there into space. Chuck, do this one. Stick figures again.
Okay, let me get back to
They're dining.
looking
they're
up
talking.
the meaning. You know, it's a sign of Asclepius was the medical thing with the single snake,
that's
but
called.
I didn't find the name yet. Okay.
Okay.
Waiter comes and he gives a menu to a person, says, and our special today is prime rib served with baked potato and vegetable of your choice. And the guy looks at the menu and he says, I'm confused. How can you serve a 12-ounce and a 16-ounce prime rib? The waiter says, I'm not sure what you mean. And he says, well, clearly they should be 13-ounce and 17-ounce to be classified as primes.
That's pretty good.
Oh.
Yeah. And those are also called adjacent primes.
Prime numbers. All right, Mr. Whittemore, get us
Uh-oh.
through these stick figures.
Okay, the first iteration of our artificial intelligence system had the brain power of a newborn baby, but it was designed to learn and grow over time.
Ooh.
We believe that it's now functioning at the level of a teenager, but we can't be sure as it won't come out of its room. Of course,
I hate
teenagers are
you.
going, I hate you. Pretty
I
good.
hate you.
Open the pod bay door, Hal.
Yeah.
Mr. President, what do we got here?
Some guy somewhere halfway between Jekyll and Hyde, and it says, hang on, I'm changing.
Kind of like that one.
Lon Chaney morphing into the wolf man behind the, Who's
Mhm.
knocking at the door, though? Is that an ICE agent?
Yeah,
I just
All right,
the,
gentlemen, we got to get
this-
serious. Take us to the heavens.
the single, just a quick note, the single snake rod sign of medicine is rod of Asclepius, not
Okay.
a caduceus.
Okay, Hippocratic is an oath, isn't it?
Yeah.
Mhm.
Okay. All right, where are we? In deep space.
Beetlejuice.
Oh,
This is-
Beetlejuice, that's a star we're looking
What
at.
a shot.
My God, it's as bright as the moon.
Yeah, sure looks like it, doesn't it? This is an image of Betelgeuse. It's a color composite
Hmm.
made from exposures from the Digital Sky Survey. So it's an attempt to make the, and this is quite a trick for scientific instruments, to make it look like it would to the human eye. Because they don't have RGB filters in general. They have specific spectral lines that they're interested in for scientific reasons, not just to make a pretty picture. But in this case, it's a very dramatic, pretty picture.
Yeah.
So this is taken from a spacecraft. Oh, Digital Sky Survey. No, it wasn't. Okay, here we go. This is an artist concept of the newly discovered Beetle Buddy. It turns out that Betelgeuse is a double
Minor.
star, and it has a small, what is it?
Friend.
Companion.
Yeah,
Companion.
companion. I'm looking
Live-in
to
partner.
verify if it's a white dwarf, but I think it's not.
No, it's not well, it's, yeah, whatever it is, it's 1.6 solar masses.
Yeah, so
Okay.
it's a sun-like star in its mass.
Hmm.
And this
Why
is,
wouldn't it be a planet orbiting it?
It's got thermonuclear fusion going on inside of it. You don't do that in a planet.
yeah.
Do they orbit a common center of gravity like some
Yes.
binaries do?
All orbits do that.
Mm-hmm.
But here, the common center of gravity is inside Betelgeuse.
Yeah, yeah.
Got it.
It's
Now,
just like our sun, our center of gravity is deep in the sun.
So that would be a red dwarf, right? It's
No,
partnered
not at that
with a
mass.
dwarf?
Not at that mass. It's got a mass more than our sun.
yeah,
Oh, it does. That big. I thought it was tiny.
Jupiter's red. Now, as this picture, this image, this artist concept implies, this companion is inside the atmosphere of Betelgeuse.
Okay.
Jeez.
So
Man.
Betelgeuse has quite an extensive atmosphere.
Wow.
Yeah, it would reach out to Jupiter
Yeah.
if it were where our sun is.
You'd
The
think it would
caption
have
says
sucked it
that
up
the
by now.
spacing between the two is to scale, but the size of each one relative to the other is not to scale.
Okay.
That's crazy. It's bigger than our sun.
Jerry,
So
is there any accretion from the little companion? Is that possible at that mass?
Sure, sure, it's sweeping up stuff as it goes by,
Okay.
emitting stuff.
Yeah, it's also leaving behind a trail. So it's leaving a wake.
Yeah.
It's basically swimming in Betelgeuse's atmosphere.
Wow.
Huh. How in the world do they find it?
Ah, so it's interesting that you should ask that question. This is the effects of the companion star wake, the wake. These are the companion star in front of Betelgeuse and the companion star behind Betelgeuse.
Oh,
So this is the wavelength of, it's iron,
Okay.
doubly ionized iron
Mhm.
in that.
Wouldn't that be singly ionized?
Yes, you're right.
Yeah, that sounds right. Yeah.
And so this is the wavelength in angstroms. This is 2,728. So that would put it in the 5,000 is the yellow light of sodium. So this would put it out near the ultraviolet or out in the blue area, shorter wavelengths. So you definitely have an eclipsing binary.
Wow.
So that's how they found the sucker.
I thought the introduction of iron in a star meant its death was over.
No, it's when it makes iron.
Yeah,
Well, where did this come from?
Previous generations of stars.
yeah.
Oh, it's already out there in the dust or whatever. Okay.
Well, this star is making iron.
Yeah.
It's coming
Well,
to the end of its life.
or getting ready to. Yeah.
Yeah, getting ready to. It's got enough that you can see the spectrum for iron.
oh, wow.
But Betelgeuse is not making iron?
No,
It
is.
may be way, way down in the core, but not in large amounts yet, because
Yeah.
that's the end of it if that happens.
Mhm.
Yeah, when that happens,
Well,
then we go
But as you
supernova.
recall, there have been a lot of strange things about Betelgeuse lately. And it's suddenly for a couple of years, its brightness dropped by a factor, I think about 30%.
It was
And
1/2 for a while.
was it? Okay.
Yeah.
And then it's close enough and big enough that we can sort of image it. It's not real sharp imaging, but the star is very turbulent and very blotchy. And that could be an interaction with this close-in companion that's causing a lot of that stuff.
Yeah, wasn't that the first star to be photographed, Chuck?
It was the first to have its diameter measured by an interferometer.
That's it. Yeah.
Wow. And it's set to go off. It'll take the other guy with it, won't it? They'll both go off, right? Or
No,
not necessarily. The little
not
one,
necessarily, but that it's close enough that it might really get disrupted.
Yeah.
the Betel buddy.
One of them is going to be in a hell of a windstorm.
Yeah.
Beetle buddy.
I missed that, Mr. President. What did you just say?
I said one of these stars is going to be in a hell of a windstorm.
Oh, God. But we're going to have a light show like you won't believe if it happens during our lifetime.
Yeah. Now we're switching to Mars. From Mars, there's a fake photograph going around showing or claiming to show the Earth, Venus, and Jupiter in the sky above Mars. See it all over the place. I tried to track that down because it would have been a dramatic photo, but apparently it's an AI construct.
Wow.
And it got the thing wrong. So if you see it out there, don't get all excited. So this is a representation of the current plan for retrieving the samples that this rover here is running around Mars in, what is it, Gale Crater?
Jezero.
Jezero, that's right. And it's pooping all these little test tubes full of Mars soil. And it's trying to remember where they are, which I think is a bad idea because the way the wind blows things around on Mars, you might never find that again, even though you know precisely where it is. But I think it should have brought them with it. But they're planning on putting another spacecraft down there that locates and finds these things and then brings them back to Earth. Sample return mission. Now, this is getting very popular among the competing space stations. And right now there's a very heated space race to do sample returns on Mars between China and the US. And with the way the budget is being cut now and the uncertainty in what the heck we're doing, it looks like China's, in my view, going to take the lead. But let's see.
In most everything.
Yes, I think if you look at these different space programs around the Earth, it's like a 100-yard dash, and the U.S. has stopped to tie its shoelace.
Yeah.
Oh,
Good analogy.
Yeah. So
More like shot itself in the ankle.
Yeah, right.
now this is a sample that has been taken, a core sample, and it has been recorded and put in a tube in this area, and it's one of the samples that's waiting to be retrieved.
Rover took a picture looking right down in the tube.
This is the sample of it in its in the
Okay,
well,
right.
it could be in the tube, it could be in the hole in the ground, it could be, but whatever it is, this is the sample.
Okay.
And it's preserved and waiting. Now, this is the Chinese plan.
Whoa.
They're going to lander ascender combination. They're going to see Earth to Mars transfer. So they're going, this is the reentry part. So they're going up, they're going to land and do a sample, and that sample will then be launched into orbit, and it will be picked up by a return or an orbiter returner launch. It will break and capture it into this gizmo, and then it will return to Earth on this, and it's going to make a hard landing on Earth. And I think I have a video of that.
Oh. They're going to get their own samples, right? Did I miss you saying?
They're
not
not,
picking-
no, they're not going to pick up our samples.
Oh, okay. That's
They're
all
going to
right.
get their own samples.
And
I couldn't get that. Oh, go ahead, Chuck.
And for a while, our sample return was in disarray because the first plan was for a second rover to go and collect those test tubes, and that takes forever. And then, with the success of that Mars helicopter, the idea got canceled, even though they'd done a bunch of work on it. And they were talking about, oh boy, a much better way to do this would be to send a little helicopter to collect those test tubes.
But they don't have dirt on Mars, so it's either
Sure,
sand
they
or
do.
rock.
There's
wouldn't you
lots of
think?
it.
It's
There's
called
lots of regolith on Mars.
Yeah,
That's
it's
what
called
blows in the
regolith.
windstorms.
Okay. Getting ready for a video?
I hope so.
I couldn't get that link you sent to work.
Well, let's see if I can get it to work.
Need an engineer over in the booth running things. Here it comes.
Oh,
Wow.
wow.
Oh, this isn't the Chinese one, but this is another plan.
Yeah.
Huh. It's an artist rendition, right?
Of course.
Okay. I like
Yeah,
the
this is the
model.
US plan from NASA. They at least had the money to run through a video.
Yeah.
Wow. There.
Now, this shows the rover style pickup, but as Chuck mentioned, they're planning on a helicopter pickup.
Oh, really?
Huh.
Their own little drone like we had then. Huh.
See how little rocket power it takes to get off of Mars compared to how much it takes to get off of Earth?
Not like the moon, right? For the Apollo.
Boy, this is going to be tough.
Mm.
Yeah. Gonna be very valuable stuff once it gets back here.
No parachute.
Not yet. Oh, not at all. Whoa.
Bam.
That Utah desert again?
Probably, yeah. Out in the proving grounds.
Wow, how could it survive without a chute?
See the logo here?
Rocket Labs.
This is Rocket Lab. That's a startup company here centered in Long Beach.
Hmm.
And let's see if I can get back here where we were.
Maybe they'll have a subsidiary out on Hollister before long.
Visit Chandra's beautiful universe. Kepler's supernova limit. A new movie.
I hope they at least have some airbags in there for those samples.
I was thinking if their glass test tubes are going to be in trouble.
Yeah.
Now, wait a minute. Did we just see the return to Earth of ours or of Chinese?
This was not NASA's plan. This was
Rocket Labs.
Rocket Lab's version of the retreat, what they're proposing to NASA.
Oh, on the current.
Wait a second, I'm having trouble getting back to Zoom.
You mean for the
Okay.
current samples that are already stored and waiting
Yes.
for us?
Yes.
Got it.
It's interesting. I wonder if they're planning to build the rover that goes and gets stuff too. That seems
They'd have to. That's what is required
because they didn't show that being landed.
No.
with drills and tubes. And my God, it's amazing.
Now this is a Comet 24P Shalmas in January 8, 2026, which was a few days ago. It's not that far away from here now. It's near Epsilon Virgo. Virginus, thank you.
Yeah. And I would say Shalmasse.
Okay, Shalmas.
Was that the Discover, a German guy?
Yes.
Yes,
Okay.
yes.
Or Austrian, I think.
Now, this is not expected to be a naked eye comet at all. It's quite faint now. It returns every, I think it's an 8-year period returning comet. It's approximately magnitude 10.8 right now.
Hmm.
So
Visibility starts about what, 5, 6?
6.
6.
Yeah.
And Tim, that star there at the center of the cup, I think it's was it Gamma Virginis?
Gamma, yeah.
Yeah, it's also known as I think Parima. It's a real nice test for your telescope, Tim, if you can split it.
Oh, okay.
It's not that tough, but
Which one is it in there?
it's called Porima. That's the way I know it. I can't.
Porima.
Yeah, I can't get. It looks maybe like a Gamma Virginis.
Yeah,
Yeah,
it
it's
is.
Oh,
gamma.
okay.
It says gamma.
Okay.
Yeah.
Okay.
And that's one where you could actually, I don't know how close it is now, but for a while it was easier. And you could
Okay.
actually,
Okay.
in a fairly short amount of time, see orbital motion in the companion.
That's pretty neat.
Yeah, that
Wow.
is.
Yeah, that was always the test star for me, Tim. When I would
Porima.
make a new mirror.
Okay.
This is a picture of Shumasa taken through a 8-inch telescope.
Wow.
Imaged on December 29. So it's fairly long exposure to get this. Classic comet, no appreciable tail.
How can they? I don't get how they track
How they what?
the comet because you can see the sky streaking by.
Yeah. Well, you get in some of the software, you get to pick the star you want to guide on.
Oh, okay.
Whatever blob of light there is there, the computer will find the centroid of it and it will keep the centroid centered.
Man, that is
It'll
something
follow
else.
the centroid. So it actually helps your guidance a little bit if you make your stars slightly out of focus.
You
So
know, in all
bigger
that we
thing
do
to determine the centroid of.
at the workshop, I forgot to ask that, and it just, I mean,
And Tim, also, if you've got a laptop that's driving your scope, you can put in orbital elements for the comet and have it track the comet. So you
huh.
don't have to have a separate camera, which is Jerry's version would be there's a separate tracking camera that's doing the guidance.
Yeah,
But you could also, I mean, you could guide optically yourself by having a pair of crosshairs and looking through a finder and
yeah.
constantly giving commands to the scope. But you can also have a laptop that has the orbital elements do that.
Huh.
I tried that back in the 60s when I first got into astronomy. I tended to fall asleep at the scope.
Yeah. Yeah, that was real masochism.
But what's the time length involved here for those streaks? How long?
This is for a what is it, a 10th magnitude comet? I would say these are probably maybe 5-minute focal, 5-minute.
5 minutes.
Yeah, I could fall
That's
asleep
right.
in that time.
What's that?
I could fall asleep in that time.
Yeah. Well, I couldn't hold myself up looking down into an eyepiece like that, so I rigged up a chaise lounge. So I was laying flat back and I had a straight through guide scope. And that's sucker bait for falling asleep.
Yeah, but the innovation is really nice.
Yeah. Okay, and now we're going to go to one of the most mysterious objects, and I have not figured out why this does what it does. So we're all going to discuss that. There's several of these in the sky. This one is called the red rectangle, and it's over here in Monoceros.
Unicorn.
Yeah, I was going to say one-eyed, but one horn.
One horn.
Yeah.
Yeah,
So
Flying
that's what
purple people
that's what
monster.
Mon means. And this is where it is, right behind between Orion and his dog. So and this is what it looks like in a long time photograph.
Whew.
Now they have an explanation which I put in here.
Why it's called a rectangle?
Well,
Yeah.
because of the shape, but it used to be classed as a planetary, but I think now they decided it's a protoplanetary disk.
That yes. The it's two cones pointed at each other. And I can see that. I can see there's like two cones. That's obviously the X. But why there are straight ladders across it? I know that something is coming out periodic, so I can get the periodicity of the rungs. But why they're straight?
Yeah.
I don't know that.
Jerry, when I saw this the first time, I remembered back in the 60s, 70s, people taking soap bubbles And there was
Yeah.
one guy that spent a lot of time taking soap bubbles and putting them together, and he finally was able to make a square bubble.
Mm.
Yeah,
I
but
thought,
they do it in a framework of things. So there's something to hold the bubble up.
yes.
Yeah. Yeah,
Well,
I've seen cubic bubbles made that way.
I was thinking that in some strange way, maybe that's what's going on here.
No, there's no frame to do it on.
Well, there could be interstellar gas or something that provides pushback, but still, to have it be so uniform is weird.
That is uniform.
Yeah. And this one, there's several of them. This one is, well, it's called the red rectangle. And this one is the Hubble version of the same one.
And those four spikes are not the regular spikes that you get from viewing through a telescope.
Yes, they are.
These
Yeah.
are.
Yeah,
They
those
are.
are.
This
Mhm.
is structure in the
Oh,
nebula.
hmm.
And this is called HD 44179, and it is not in any of my planetarium catalogs. So I can't show you exactly where it is.
Mhm.
But that's
Henry Draper, right?
yeah,
Yeah,
and
HD, yeah.
and that's also the red rectangle.
Yeah.
One
Now this
of the
one,
pictures in your talking points, Jerry,
which one?
have a caption saying red square.
That's another one.
Well, that's a different one. Okay.
Yeah.
Yeah.
There it is.
Yeah,
This
that's
is
in
the-
Moscow.
This is the red square one.
I see. Okay. I thought it was a misnomer.
And this actually was the APOD photograph for September 6th. I've left a digit off there, but a while ago.
Gotta tell you, gentlemen, you just don't get these kind of shapes in space.
So here's
Now
the
that
answer.
does look like a planetary.
Looks like a red square to me. How did a round star create this square nebula? And here's the answer. No one is quite sure. The round star known as MWC 922 and possibly part of a multiple star system
Wow.
appears to be the center of the Red Square Nebula. The featured image combines infrared exposure from the Hale telescope on Mount Palomar and the Keck-2 telescope on Mauna Kea in Hawaii. A leading progenitor hypothesis for the square nebula is that the center star or stars somehow expelled cones of gas during a late development stage. I can see a cone of gas. For MWC 922, this feature, these cones happen to incorporate nearly right angles and visible from the sides. That makes no sense to me.
Well, Jerry, if you take the going from upper right to lower left, and make that an axis,
Yeah.
and then view it from that point, turn it 90 degrees towards us, maybe that's circular.
Yeah.
And then so when you flip it over 90 degrees, maybe that's when it appears to be a square.
Yeah. We're viewing from the side.
We're
No, I
viewing
follow
it,
that.
we're viewing it from the side, and if you turn that 90 degrees towards us, and that'd be a circle.
Mhm.
Was this picture taken by the web since it's so red?
Oh, I see. You claim we're looking at a circle flat on.
Yep.
From the edge.
Yes, yes.
Yeah,
Exactly.
Ronnie, Jerry just said this is a combination of Keck and Palomar images in
Yeah.
infrared.
Oh, in infrared. Okay, got it.
Yeah. So Earth-based scopes.
It's
And
near.
infrared can still highlight the center, which is yellow and white.
Okay. Yeah, I understand that. I think your explanation is correct. We're looking at progressive circles of burping out things.
Yeah.
Yeah, very good.
That seems right. That seems right.
Yeah, I like that.
I love it. I think it looks pretty.
So it says supporting evidence for the cone hypothesis includes radial spokes in the image that might run along the cone walls. Researchers speculate that the cones viewed from another angle would appear similar to the gigantic rings of supernova 1987A, possibly indicating that the star MWC 922 might one day itself explode in a similar supernova.
Whoa,
Seems good.
all these impending novas. I had something on my Christmas tree look just like it.
Oh, I left one of the things I added to the write-up, but I didn't put it in the let's see, I got it.
Talking points, you missed something?
Yeah, I think I missed a
There was a diagram showing a
yeah.
proposed orientation.
Oh,
Oh,
there
we
it
can
is.
go-
Yeah, oh, it's unnumbered. That's what's the problem.
Well, for doing one of these each week of the 52, week year or 52 week year, shame on you, Jerry, for
Yeah,
forgetting.
Shaylee. Oh no, I've screwed up before. You just guys haven't caught it.
We
Okay,
can go, we can go anywhere you want, Mr. Perez.
now this is another picture of MWC 992 in Serpens Cauda. And I expect an ovation from finding the word Cauda there, because that's almost the whole day. Everybody thinks Serpens. What else do you need to know?
Yeah.
So anyway, yeah, this explains exactly what you're talking about down here. There's cones of light going out and there are rings, and we're looking at them straight on from the edge.
I think so.
Yeah. Okay,
Has to be a
good.
pretty perfect orientation to give you that square effect.
Yeah.
Good Lord.
So I think there are 4 or 5 of these in the skies. Very nice. But I think my quick read of it is they're all too faint to be picked up easily in an amateur telescope. But if you know the coordinates of them, which can be difficult to find too, then you can go look right there.
I'll just use a little star hop, Jerry.
Yeah. Well, it's up right now, so there's a chance tonight you could give it a shot. At least the one in Monoceros.
We'll give it a shot on Friday night, maybe. I like these things Jerry puts out there, and then I can test them on the next star party. It was really cool, by the way, to get the public to look at that companion star and guess the color. That was really fun, and they liked it too. Some people saw purple like me, and some
Yeah.
people saw pink, others orange, red. The consensus was red, orange.
Well,
But
Tim, why don't you tell us about that on December's meeting? God bless you. I'd love to hear it.
oh no, I've been working on the PowerPoint, which somebody's going to have to help me with, and already I've got it cluttered.
Well, Totten will do it, I'm sure. Tom will help you.
Good, good.
I see a spur that we're on. The old-
Yes, this
There
is
we go.
this is a representation of our galaxy, the Milky Way. You can
Oh,
see that we are in this representation, obviously not a photograph.
Yeah.
We are a barred spiral. Right there, there's the bar. And we have a couple of arms going here. This is the Sagittarius arm. This is the Orion subarm right there, which we are in right there. And this is the Perseus arm. And the what we're going to look at is the brightest supernova remnant in the radio sky. That is, it's not particularly bright and visible light, but it's a humdinger in radio waves at 1 gigahertz. And that's located out here in the Perseus arm. It's the next arm over. It's called Cassiopeia A, and don't mix it up with Sagittarius A star, which is a black hole.
Yeah.
But this one is located in a few degrees off from the galactic anticenter. Now, it's not something you run into every day, just calling it the anticenter. And the diameter here is 40 kiloparsecs. And you recall that a parsec is a little over 3 light years. So this is about 3 times 4, it's about 120,000 light years. So it's roughly the size of our Our galaxy is estimated to be about 100 light years long. This is not a picture of our galaxy. It looks like a picture to me of M101, but the stuff is superimposed on it as if it were our galaxy.
Huh.
So this is the galactic center right here, because you notice this galaxy has no bar, but it's a real photograph.
Oh,
Yeah, as a matter of fact, it's the background photograph on my image here, but which I took. But here is the galactic center. Here's where the sun would be, this proportion of outward. And then this is the anti-center. So it's exactly opposite in the sky from the galactic center. And that is where the what is it? Sagittarius A is.
Oh, Cassiopeia A.
Cassiopeia. Now I'm doing the mix-up.
Yeah.
Okay, and this is a white light photograph. I believe it's taken by a 24-inch Ritchie-Cretan telescope at Mount Lemmon. And this is a good representation of what you would get in an amateur telescope of the supernova remnant. Now, this supernova remnant, I believe, if memory serves, was 11,000 years ago, or it's 11,000 light years away. Do I have a date for it in here? Do you?
I think isn't this this is thought to be the Kepler supernova remnant.
Yeah, I think that's what Kepler saw.
So that was seen in like 1604.
Mm-hmm.
you mean the actual nova?
Supernova.
It's 340 years old.
Yeah.
That's it.
That's it.
Yeah.
Yeah, I remember it.
Yeah.
Okay.
Yeah, right.
And
I must have been looking the other
the
way.
other image you have shows a like a hole that got punched in it, like a tube, and they think that the remnant got or a companion got a recoil effect and got shot out of it.
Can we view this visually?
Yeah, this would be a visual look in a 26-inch scope if you had really good eyes. This is a photograph, a long-term photograph, probably an hour long or something.
Okay.
Doesn't give the length of time. But I would say no, this is taken by the 24-inch Ritchie-Cretan at Mount Lemmon Observatory.
I bet a sea star could pick it up.
No.
No?
But get your radio or X-ray eyes on.
Oh,
This is visible light though, but it's super bright. Let's see, do they give a size here? It's moving outward at 31 million miles per hour. So you can see the light echo of it as it grows. No, I don't see a size limited distance here, but this is a combination, a false color image of Cass A using observations from both Hubble and Spitzer telescope, as well as the Chandra X-ray Observatory.
good.
Now, you notice that the Chandra X-ray Observatory, of course, is way out there, but the Spitzer is an IR, one infrared. The Hubble is visible and near IR. So you're getting a lot of different wavelengths. So this is not a true representation of brightness in any one band.
Wow, it's
And
colorful.
you can
But
see
this-
that path where it looks like something blew out of it at about the 10 o'clock position.
Yeah, right there. There's the cannon's barrel.
Yeah.
Boom.
Different colors represent different elements that were made.
Yeah, it's false color.
I understand that, but they wouldn't put it on there if it didn't have a meaning, I would
No,
think.
it didn't, but
Some of them are X-ray, some of them are infrared, some of them are visual.
This remnant of a supernova contains iron, silicon, sulfur, and calcium.
Whoa.
So it's a good representation of what the supernova was churning around in on that when it went off.
Dumb question time. Most stars that go supernova, are they red giants like Betelgeuse, or can a star the size of our sun do that?
No, we don't have enough mass to go supernova.
Yeah.
So this was probably a red giant.
Probably a supergiant before it went off.
Yeah.
The supergiant, that's even bigger than
That's like
Betelgeuse?
Betelgeuse.
Oh, that is Betelgeuse.
That's yeah.
Supergiant.
Betelgeuse is a super giant.
So only the big ones. Certainly red dwarfs don't do
No,
nova at all. They
no,
last forever, don't they?
pretty much.
Okay. So this star, this remnant, is magnitude 8.5 visually. So you would be able to see a remnant in this in a good scope.
Although it's spread out, that's an integrated
Yes,
magnitude.
it's spread out. So sometimes when you get a magnitude like that that looks encouraging for an extended object, you got to figure it being spread way out and a lot dimmer. M33 is the most famous for that, in my view. But this one is located at the galactic anti-center close to it, in the constellation Auriga, and it's near the Crab Nebula and Beta Tauri.
Well, this one's in Cassiopeia.
Yeah, oh,
But
that's
the
right. You're right.
galactic anti-center is in Auriga.
Yes. Yes.
Anticenter. Learn a new word.
Now, this is very interesting.
Yeah.
This is the light echo of Cassiopeia A supernova. And what it means is that you see the colors. These are because it's going outward, and you can see this in the Crab Nebula too. The thing is going out. And so they take a picture of it every few years. Here they're different dates, and they're color coded. Things that were taken in February of 2005 up to January of 2008 have these color codes. So what is this, sort of a neon green and this hot pink? So you go from the green to the pink, and that's what has moved in these times.
Well, this is not expanding debris from the supernova. These are light echoes.
That's right.
So this is where the light is reflecting off of dust clouds and gas clouds. And
Yes.
getting a replay of the supernova explosion. So if they can take data like this, that's time spread out, then they can get an idea of the brightness curve of the supernova when it went off, even though it
Yes.
happened when Kepler was alive.
It's still reflecting after all these years?
Well, the light is traveling out. So these clouds are 300 light years away from the explosion.
Right. What he's pointing out is like something that's expanding, and there's a strobe light going off, or a flash bulb goes off, and it takes a picture of the cloud. And then later another flash bulb goes off, the cloud has moved, and you take another picture of it, and you superimpose them.
But it's not really a moving cloud. It's the light echoing off of clouds that are already out there.
That's true, yes.
And actually, they wouldn't be 300 light years away because the light has to go hit them and then come hit us. So they're some distance away, and you can start figuring that out too.
Why am I looking at this picture and thinking of Mickey Mouse?
Okay. I didn't notice that till you said it.
With a big nose.
Yeah. So it's
These are
mapping
not
out
all
the
the same
cloud.
supernova, are they? Are they? These are all three of those are the same?
No, yeah, this is light from the supernova reflecting off clouds as it travels outwards.
Let me make an analogy. So at night, or say a guy in a cave is going to take a picture of the cave. And so he goes and he stands down someplace and he sets off a flash bulb, and his camera's on all the time. And then he goes farther into the cave and sets off another flash bulb. The cave didn't move, but he did, and his light is traveling down into the darkness of the cave. So you get this picture with light showing different parts of the cave. So it's like that.
But we're still looking at a nova. And did I miss the part where there's something left over at the center?
This is the Cassiopeia A explosion that we just looked at, the remnants.
I know, but that means a star that exploded.
Yes.
Right there.
And left behind something we probably can't see.
No, there
like
it is.
A neutron star or a white dwarf or
Something.
a black hole.
I don't think they've found the remnant in the middle of the Cassiopeia A. And that's why they think it got shot out along that tube that we saw at 10 o'clock.
Oh, okay.
Usually novas are left behind or totally. Do they
supernovas, Ron?
Supernova. Okay, there's kilonova, supernova.
Yeah.
I lose track of those things, but
I
Okay.
like the analogy, Jerry, even though I'm kind of struggling to understand it here.
Yeah.
Well, this would be if you could see things really far away, this would be like setting off a powerful flash or like a nuclear explosion. And first you see the reflection from the mountains near you, and then 100 miles away you see the reflection from mountains even farther away. Now, light
Okay.
is so fast that on the Earth you wouldn't detect much of a difference there. But here in space, these things are really far away.
Okay. Okay.
Actually, they have made a camera that can photograph light as it travels across the room.
Yeah, okay.
Does exactly that effect. You can see it light up certain part of the room and then later light up another part. I had thought this thing in the center was the remnant, but maybe not.
It might be.
Well, what are remnants usually? Neutron, black hole?
No, big clouds of debris.
They don't, and nothing's left as a centerpiece.
No, you could have a neutron star left at the center, or you could have a black hole, or it could have been shot out and you have just the cloud of debris that you're looking at.
So it's just a crapshoot, There's no forecast of how any of those things are going to
Yeah.
end up.
Right.
There's the crab right there.
Although mass can tell you a little bit about it.
Really.
Now, this is another situation, just like the Cass-A. This is Messier 1, which looks like a planetary nebula, as well I know, and but is a supernova explosion. And it is also expanding. You can take pictures of it, and it is expanding a little bit. You can see it in different exposures, and it also shows a light echo, which is a different effect. So you can see in here, there is a white dwarf or whatever it is that's in the middle.
This is really blown out, so we're not able to see
I'm
that in
sorry.
this image.
Okay.
Fascinating stuff here. Hello, kitties. Hi, kitties.
If we could look ahead millions of years on something like that, would there be just the possibility of maybe one new solar system made, or could it generate many?
This stuff's spreading outward, so it would have to come to some spot where there was a, density clump in
Okay.
it.
Now you can see that in here there is a pulsar in there, and it's sending out, see this halo here?
Oh, yeah.
There's another halo out here farther. So it is sending out pulses of light.
Yeah, about 33
and
milliseconds.
material. So it's a very active core.
I've never
And
seen
in
that.
some of the images, you can actually see the jet, which is coming out kind of at the 7 o'clock position and
Okay.
the 1 o'clock position.
Yeah.
Yeah.
Right there.
Yeah.
Yeah, they make a hell of a mess when they go.
And it usually happens once it hits the Fe iron level, right, of making new elements.
When you make iron in the core, you can't make energy anymore, and the star collapses.
Yeah.
And it gets the higher elements during the explosion.
Some, yes.
When the star collapses, when it stops producing energy to push against gravity, then gravity is unopposed. And all the material all of a sudden slams together in the middle of the star. That causes a spike in temperature, but it doesn't cause fusion. And then it explodes outward.
And that's how we get, for example, uranium.
Well, some of those really heavy elements are made in the kilonovas when neutron stars explode. So what you get in the supernova explosion is some small amounts of some of those heavier elements, but pretty much iron and nickel are where it's at.
How many elements on the regular table are above iron? Do you know?
Quite a few.
How many?
Quite a few. I don't know how many. What is it? It's 26, right? And there's almost 100 more above that.
And none of them are made during normal fusion. It's always made during the explosions.
During an explosion, you can get some of that made in red supergiant stars in their atmospheres with neutron capture and stuff like that. And you get some amount made in the supernova explosion, but not large amounts. Large relative to the size of the Earth, but not large relative to the amount in the universe.
Well, is a plutonium a normal element, or did we make that like californium and fermium and stuff like that?
Plutonium we made first, but it has been detected out there.
Yeah. It
And
doesn't
it's
last long. It's unstable. That's why it's produced, but then it goes away. It decays.
Yeah.
It's a higher number than uranium.
Yes.
Uranium comes in two numbers, but those numbers have to do with the neutrons and the
Comes
Those
in
are
more than-
isotopes. Those are
more than two.
isotopes. And there's more than two. Yeah.
U-235, U-238, that's all
Yeah.
neutrons, right?
Yeah.
The
Yeah.
number stays the same, whatever the number is.
Yes, it's the weight that changes in isotopes. Okay, this picture, our last topic, is a pulsar. The bow wave made by a pulsar as it moves through interstellar space in our galaxy. There's galaxies in the background. This was taken by Adam Bloch at Mount Lemmon Observatory. And this is actually a white dwarf companion of the pulsar because the pulsar is too faint to be seen.
Wow.
And this is a picture, a close-up of the
The
bow
red
shock.
is a bow shock.
Yeah.
The pulsar is the little red
And
thing.
the article written by what's his name? Adam Bloch is shown in the talking points.
Ronnie, that dot there, like Jerry just said, is the white dwarf companion of the pulsar. The pulsar is not bright enough and visible.
Okay, where is the lemon?
Above
It's in
Tucson,
Arizona.
Where,
Tucson.
somebody contacted me recently wanting to do a report at one of our meetings about visiting that scope.
Brian Green?
Yeah, I said by all means, but it'll have to be in October or November. Maybe if he's a member, we can get him along.
Yes, he's a member.
Okay, we'll have him and Tim Crawford together on December. Are we done? Did we do it
We
again?
done. We done.
I think we'll be back again for number 256 of the Astro Hour next week. Meanwhile, come join our gang with
Now,
telescope.
the preview of coming attractions, I will include some pictures I found too late to get into this one. And that is protoplanetary disks, where an outer disk is like this and an inner disk is like this.
Whoa.
There's another word,
Another
protoplanetary.
X.
Yeah.
What the heck does that mean? Protoplanetary. I had a hard enough time understanding planetary nebula. Anyway, gentlemen, we're
Okay.
everywhere. We'll see you in Westmont, and we can have our own way of saying goodbye.